Let's start then. Okay, Akash, now listen here. Our topic is chemical reactions and equation. What is meant by the chemical reaction? Yes. Okay. Do you know about the physical change and the chemical change? What is meant the physical change? What is meant the chemical change? Very good. Chemical change means there is a change in the chemical composition. Yes. And the physical change is a temporary change, chemical change is a permanent change. In the physical change, no new substance is formed, and the chemical change, new substance is formed. Okay. So, these are the chemical changes we discussed. So, that chemical change only is called as a chemical reaction. Okay. So, chemical reaction is nothing but a chemical change. Okay, is nothing but a chemical change. Chemical reaction is also called as what? A chemical change. So, here chemical change means what? There is a change in the composition. In the composition means what? How it is made up of. The composition changes, new substance forms, and it is mostly generally they are irreversible reactions. Means what? They cannot be changed back. So, that is called a irreversible reaction. So, those chemical changes only are called as a chemical reactions. Is this clear to you? Right. So, now when we come to the chemical reaction, if you see one example, okay, example. For example, if you burn the magnesium ribbon, or generally you take simply you take carbon, okay. So, when carbon burns in air, okay, burns in air, then you know that it forms carbon dioxide. What it forms? Carbon dioxide. Okay. So, here if you take the carbon, okay, whatever the properties are there in the carbon, if you check carbon is burning in air, then it forms the carbon dioxide. If you see the properties of carbon dioxide, is quite different from the carbon. Yes or no? Here new substance is forming. Now it is not carbon now, it is a carbon dioxide gas. So here no properties of carbon will remain in that one. So new substance and new properties are formed here, and once the carbon burn in air, it's forming the carbon dioxide. Can you change again the carbon dioxide into carbon? No. So when carbon you burn, then it forms carbon dioxide. Carbon dioxide cannot be again changes into the carbon. Yes or no? So this is called a chemical reaction. Is this clear? Chemical reaction? In this chemical reaction, what are the substances? What are the components are reacting with each other? Okay, they are called reactants. What they are called? Reactants. So here carbon and oxygen are combining, so they are called reactants. Okay, and what is the new substances forming after the reaction? After combining these both, what are the new substances forming? That substance is called as a product. What it is called as a product. So the substances which are reacting, means which are combining, they are called as the reactants. The substance which is forming after the combination or after the reaction, they are called as the products. If two are there, two or more, then they are called products. If one is there, that's called a product. So here reactants and products. Is this clear to you? Now this is called a chemical reaction. This is chemical reaction. So to write the chemical reaction, generally if the same reaction is there, so if you want to write it on a paper, if you want to write in an examination, how to write this one? So what do you write? Okay, carbon burns in air, okay, to form carbon dioxide gas. Okay, so this is the sentence, and this sentence approximately 3, 4, 5, 6, 7, 8. Okay, approximately it consists of 40 letters. If you check, so if you count, the number of letters will be approximately 40 letters. So in the chemistry, you come across so many, okay, thousands of reactions, right? So every time it is difficult to write each and every reaction in this way. So that's what we write in short. Okay. So how can we write here? This is carbon. So I'm writing here carbon. Okay. So burns in, instead of burns in, I'm writing oxygen or air. Sorry, plus. Okay. Burns in, I'm writing plus. For air, I'm writing oxygen. To form, I'm writing, giving the arrow mark, and then I'm writing carbon dioxide. Okay. So like this, I'm writing the chemical reaction. So here 40 words, 40 letters are there, but here I compressed to 15 or 20 words here, 20 letters are here. Is this clear to you? Now what I do, I feel this also difficult to me to write this many letters. Okay. So now I would like to make it simple. So simple. So carbon, just instead of writing total carbon, I'll write just C, because C is the symbol of carbon. Now next see oxygen, instead of oxygen write O2. Oxygen molecule, oxygen symbol is O2. Oxygen gas symbol is O2. Now gives us carbon dioxide, carbon dioxide. Okay, carbon means carbon, di means two, oxide means oxygens, two oxygens. One carbon, two oxygens. Now this is called, what it is called? Yes? Now this is called the chemical equation. Okay, this is called the chemical equation. Okay, so chemical reaction is nothing but a chemical change. Chemical change only we are writing, okay, by using the symbols and formulas in short. That is called as a chemical equation. So chemical reaction we can write in short by using the symbols and formulas, and that is called as a chemical equation. Is this clear till here? Right. Now, whenever you write the chemical equation, you have to remember some, okay, points. First one is what? Generally, which are combining these both, okay, which are participating in the chemical reaction, they are called as the reactants. What they are called? Reactants. Okay. So these are called the reactants. Okay, I am writing here. So they are called the reactants. Okay. And what is forming after the chemical reaction is called product. Okay, product. Now generally reactant should be written on the left side, where we should write a left side, and the product should be written on the right side. Okay, products should be written on right side. So this is left hand side, okay, and this is right hand side. Okay, and these reactants and products are joined by arrow mark. Which mark? Arrow mark. So arrow mark here in the nose, or we can say this pointer of the arrow mark pointing from reactant to products, means what these are reacting, we are getting that is a product. Is this clear to you? Next, if the reactants 2 or more than are there, if 2 or more than 2 are there you think, then you can join by using the plus. Okay, so here you see, here we have the 2. So carbon is different, oxygen is different. So we are joining with the plus. When 2 or more reactants are there, then we join with the plus. Similarly, if it is only one product, we need not write any plus in the right hand side. But if the product sometimes may be more, so in such cases, you here also can join with the plus. Is this clear to you? Now, here this is a chemical, okay, equation. But this chemical equation, if you see, okay, this is not giving complete information. Okay, like okay, C a carbon means carbon, okay, I know C means carbon, O2 means oxygen, giving rise CO2 stands for carbon dioxide, it's okay. But here What is the state of the carbon? Generally carbon is solid. What is the state of oxygen? Generally that is a gas. What is the state of carbon dioxide? So that's also of course gas. Okay. So whenever you write the chemical equation, then the equation should be more informative. Okay, equation should be more informative. So to make more information, you have to mention the states of the reactants and products. If it is solid, then just beside of the carbon as down, you have to write S. Okay, so S stands for solid. And this is oxygen gas. So you write it is a gas. And it is forming the carbon dioxide. So this is also gas. Is this clear to you? So generally remember here, if anything, okay, solid is there, then we write a small like this S. If it is liquid is there, then we write L. Okay. If it is gas is there, then we can write G. Sometimes if some salt is there, salt cannot directly react with other salt. So that's what we do. Salt we mix with the water and makes a solution. And this solution we mix with some other solution, so the reaction is taking place. If such water solutions are there, they are called aqueous solutions. What they are called? Aqueous solutions. And when it is aqueous solutions are there, okay, aqueous solutions are there, just you have to write AQ. Okay, AQ represents aqueous solutions. Okay, now sometimes what happens, here see, when your carbon is burning in oxide, forming the carbon dioxide, so that is gas. Generally you know that gases will move upwards, yes or no? Gases will rise up. Is this clear? So that's what generally for gases, you know, we can write like this also, or we can put for gases. Okay, if the gases product is there, okay is there, then we give the upward arrow mark. What we give? So you can write the same equation like this also. Cs plus O2 gas, so that gives rise to CO2, and just give the arrow mark. So if you give the arrow mark means what? That's a gas, and that's a gas. Is this clear to you? Generally arrow mark should be written on the product side only. Okay. Now sometimes you know, sometimes when two substances are reacting, okay, in that one liquid and one solid, two products will form. When two substances are reacting, maybe sometimes what happens? Two products will form. One may be liquid, one may be solid. Okay, so solid will be settled at the bottom. So in such cases, that is called a precipitate. What it is called? Precipitate. For that, what we give? We give arrow mark down. So arrow mark down means what? For example, if anything a reaction is taking place, so some solid is formed. For example, you think some solid is formed, the solid will settle at the bottom like this. Okay, so the solid will be settled at the bottom, and some liquid may be formed here at the top. So this solid which is settling at the bottom, okay, this when we represent this one, you give the arrow mark downwards. So that is called precipitate. Is this clear to you? So take the screenshot of this one. Done. Right. Now, now see, listen carefully now. So now that is about the chemical equation. But here what happens, you see, for example, the previous slide once again see here. Okay. So here one carbon symbol is C, and burning in oxygen formula is O2, and giving rise to carbon dioxide CO2. Now you have to check how many atoms are there in the left side, how many atoms are there in the right side. So here how many carbon atoms is there? How many carbon atoms are there? Only one. Yes or no? Now here you see the right side. In the product side, how many carbon atoms are there? Only one. So both are correct. Now here you see how many oxygens are there here? 2. O2. And here also in the carbon dioxide O2. So 2 oxygens is there. Yes or no? So the number of atoms in the left side is equal to number of atoms in the right side. This the total number of atoms present in the reactants is equal to total number of atoms present in the product. Is this clear? Right. So, according to law of conservation of mass, already we discussed this one. So, according to law of conservation of mass, okay. So, according to law of conservation of mass, law of conservation of mass, the total, okay, the total mass of reactants, okay, should be equal to the total mass of the product, okay, because mass can neither be created nor destroyed. Mass can neither be created nor destroyed. The total mass before and after the reaction should be same. Is this clear to you? So instead of mass, you can also write like this. So according to law of conservation of mass, the total atoms, okay, or elements, anything in the reactants, is equal to total number of atoms in products. Okay, is this clear? So total how many atoms will be there in the left side? The same number of atoms should be in the right side also. Okay? So this is called law of conservation of mass. Take the screenshot of this one. Right. Now, for example, I have one more equation, one more chemical reaction. I am taking magnesium ribbon. What I am taking? Magnesium ribbon. Okay. So magnesium ribbon. And I am burning this magnesium ribbon. Okay. Magnesium ribbon burning in air means oxygen. Okay. So what the product I get is where magnesium ribbon burn in oxygen to form, okay, to form magnesium oxide. What I will get here when I burn the magnesium? Magnesium oxide. So when I burn the magnesium, so I will get the magnesium oxide. Then what I do, I try to write this in the chemical equation form. Okay, means by using the symbols and formulas. So magnesium, what is the symbol of magnesium? Mg, very good boy. So magnesium symbol is Mg. Plus burning in oxygen, what is the symbol of oxygen? O2, good. So I'll write O2. Now what is the formula of magnesium oxide? We already discussed how to write the formula. Magnesium oxide means you have to write magnesium and oxide means oxygen. What is the valency of magnesium? You forgot, I think. Magnesium valency 2, oxygen valency 2, then you have to crisscross. So this becomes Mg2O2. When same numbers are there, we can cancel. So we'll get MgO. Okay. So we get what? MgO. So that's the formula of magnesium oxide. You have to practice. If you don't practice the chemistry, it's not easy. Okay. So magnesium when burned in oxygen, it forms magnesium oxide. The symbol of magnesium is Mg. Symbol of oxygen is O2. Symbol of the formula of magnesium oxide is MgO. So this is correct. Magnesium symbol is Mg, correct. Oxygen formula is O2, correct. Magnesium oxide is MgO. That also correct, right? Now, but overall if you see the reaction, overall if you see the equation, if you write this equation in the examination, then this is wrong, the marks will not be given to you. Okay? So, individually if you see, this is correct. Magnesium symbol Mg correct, oxygen formula O2 correct, magnesium oxide MgO correct. But if you write in the examination this one, this is wrong, you won't get the marks. Now the question arises that if it is correct, if your magnesium is Mg, oxygen is O2, magnesium oxide is correct, then why overall it is wrong, why I do not get the marks? The reason is that, just now I told you that according to the law of law of conservation of mass, the total number of atoms should be equal to total number of atoms in the product side. Yes or no? So now you check how many atoms are there. Like for magnesium in the left side, only one is there. Very good. Now how many magnesiums are on the right side? 1. So magnesium is balanced. Okay. So if you want, we can make one small table also. Okay. So you can make one table here. So you write here magnesium and you write oxygen. This is in the reactant side. This is the product side. So magnesium reactants, how many are there? 1. Product side, how many are there? Only 1 mg. 1. It's okay, good. But oxygens, how many are there here? 2. So the reactant side 2. But the product side, how many oxygens are there? Only 1. Only 1. Yes or no? So this is not balanced. The total number of atoms in the reactant side is not equal to total number of atoms in the product side. So that's what this equation is wrong. Okay. But actually what the according to symbol what you written, this is correct. So this equation is called skeletal equation. What it is called? Skeletal equation. Okay. So skeletal equation is what? When you write as it is, the chemical reaction you are writing by using and symbols, what you are writing, that is called the skeletal equation. And this skeletal equation do not obey the law of conservation of mass. So yes, in this the total number of atoms in the reactant side is not equal to product side. So this is called skeletal equation, and this equation is also called unbalanced equation. What it is called? Unbalanced equation. So that's what when you write this equation in the examination, then you don't get the marks here. Clear? So now to get the full marks, then what I have to do? Okay, then what I should do, sir, to I want full marks? Then you have to need the balance the equation. Okay, you have to balance the equation. Balancing means what? Making on both the sides the total number of atoms same. That is called balancing of equation. Clear? So now for example the same equation I will write here, skeletal equation of magnesium. So here I see I am writing magnesium plus oxygen gives rise to magnesium oxide. This I have written. This is not balanced here. Yes or no? So I made one small table also. Not required, but okay. I'll made here one small table. So this is Mg, this is oxygen. Here before the reactants time, this is product side. Okay. So magnesium left side right both are 1 is there, but here oxygen's left side 2 are there and right side 1 is there. So now to balance the chemical equation, what you have to do? I have to make this also 2. Yes or no? 2, 2, 1, 1. So then it will be balanced. Is it clear? So how can I make? So for that can I write this here? 1 magnesium, here 2 oxygens, here 1 magnesium, but here 2, here only 1 is there. So can I write it 2 here? So that it becomes MgO2. So both sides the number of atoms become equal. Can I write? Now can I write like this? O2. So 1 magnesium, 2 oxygens, but only 1 was there, so I am writing 2 here. So is this correct? No. So this is the wrong method of writing we should not write like this. Okay. Then what we have to do is, whenever you want to write, okay, whenever you have to balance the equation, you should not write 2 there. Then where you have to write Mg plus O2 gives rise to MgO. Is there no? You should not write 2 here. This is wrong. Okay, that is wrong. Okay. Then where you have to write, always you should write in front of the product, in front of the compound. Whatever the compound is forming here, before that compound you have to write the 2. Is this clear to you? But when you write 2 here, then what happens? 2 oxygens here, 2 oxygens here, balanced. But here we have written 2 in front of magnesium oxide. So the meaning is what? Magnesiums also 2 are there here now. But here only 1 magnesium is there. Now we balance oxygen, but magnesium becomes unbalanced. Yes or no? So now in the next step, what you have to write? Okay, so next step Mg plus O2 gives rise to 2MgO, right? So here two oxygens are there, two magnesiums are there. Two oxygens are there. You have to balance two magnesium. So here you can write the 2 in front. Always should be written in front of the compound only as a coefficient. Okay. So now if you check two magnesiums here, two magnesiums here, two oxygens here, two in front of magnesium oxide means what? Two oxygens here. So now it is balanced. So this reaction is, this equation is called okay, balanced equation. Clear? So first you do one thing, you take the screenshot of this one also. This you didn't take, I think. Take the screenshot of this one. Then go to the next slide also. Next slide also take. This slide also take the screenshot. But all you have to write in the exam, in the notebook very clearly. Now I am going to explain two more chemical equations, and then I will give 3-4 chemical equations to balance as a homework to you. Clear? Okay. Right. So now, okay. Now what? So here, so here I am writing hydrogen H2, oxygen O2 gives rise to water. This is first equation. Okay. Second equation, hydrogen plus chlorine gives rise to hydrogen chloride. Third equation, hydrogen plus nitrogen gives rise to ammonia, NH3. Okay. Next, what can I give? Okay, fourth one. Okay, sodium Na plus O2 oxygen forms Na2O, sodium oxide. Fifth one, okay, sodium plus instead of sodium I'll take water now. Okay, so instead of sodium I'll take okay, magnesium I'll take, otherwise magnesium, okay, anything I can take. Okay, I'll take calcium. Calcium plus water gives rise to calcium hydroxide, CaOH taken twice. Sixth one, what can I write? Okay, so like calcium is done, no? Okay, aluminum, right? Aluminum plus oxygen gives rise to aluminum oxide, Al2O3. Chalo, take the screenshot of this one. 6 are there in that 2. I will explain you. Na2 your wish, and remaining 4 you have to do that as a homework. Clear? Take the screenshot of this one, and then you tell which 2 shall I solve for you. Fifth one. Okay, so fifth one. So fifth one is calcium plus water, H2O, gives rise to CaOH taken twice. Actually this written wrong. Okay, that is not CaO should be there. What it should be there? CaO, but it's already balanced. This calcium oxide is actually calcium oxide in water gives rise to calcium hydroxide. So that's balanced. You take other one. That's already balanced. That is what. Okay, I'll take aluminum once again. Aluminum plus nitrogen gives rise to aluminum nitride, ALN, aluminum nitride. Now you say, now which two shall I solve it? Yes? You can do all. Okay, then I'll explain one to you. I'll explain this third one explaining. Okay, third one, hydrogen plus nitrogen gives rise to ammonia. Okay, so hydrogen, this I'll rub. Hydrogen, see here, hydrogen plus nitrogen gives rise to ammonia, NH3 is there. Okay, so here what you do is, two hydrogens are there here, but here only, here three hydrogens are there. Okay, and here two nitrogens are there, here only one nitrogen is there. Okay, so this you can do in two ways. Okay, if you want to balance first with the nitrogen, that is easy actually. If you want to balance first with the nitrogen, so here two nitrogens are there, here only one nitrogen is there. Yes or no? So what you do? H2 plus N2 gives rise to NH3. So here you see two nitrogens are there, but here only one is there. So for this, what you have to do is, you write 2 in front of this one. Okay, 2 NH3. Now see here two nitrogens, here also two nitrogens. It is balanced. Yes or no? But hydrogens you see. Now here two hydrogens are there. Here how many hydrogens are there? No, 3. This 2 is also there. No, 2 you have to multiply this with all. So 2 3s are 6. How many hydrogens are there? 6 hydrogens are there. But here 2 are there. So now what you have to do? With what if you multiply this 2 to make it 6? 3. So you have to multiply with 3. So that's what you do here. Now you write the 3 here. So 3H2 plus N2 gives us 2. Now 3 2s are 6 hydrogens here, 3 2s are 6 hydrogens here, 2 nitrogens here, 2 nitrogens here. So that is balanced. Is this clear to you? Now if you are doing with the nitrogen, for example, if you are starting with hydrogen, then what can you do? So here you see, hydrogen plus nitrogen gives rise to NH3. So if you want to, here I am started with the nitrogen. So first I balance the nitrogen. But you want to balance first hydrogen. So then what you have to do, here two hydrogens are there, here three hydrogens are there. So in such cases, how to balance is, see, this is 2, this is 3. So now to this 2 you multiply with the 3, for this 3 you multiply with the 2. So then what it become? It become, see, here 2, here 3 are there. So I am doing multiplying with the 3 this one. So now this become how much? 3 2s are 6. Here already 3 is there. So what I do? I multiply with the 2. So 3 2s are 6. Is this clear to you? So here 2 is there, here 3 is there. So with this 3 you multiply here. With this 2 you multiply there. Now it becomes, so you multiply with this 3 to this one. So this becomes 3 NH2, 3 hydrogens, 3H2. Now here you see here, I said this keep as is, this don't do anything. Okay, gives rise to, here you multiplied this 2 with this 3. So there you multiply with this 2 now. So write 2 NH3, multiplying with the 2 here. Because that 3 are multiplied here. So this 2 you multiply there. So this becomes. Now within one step only the equation is balanced. So here 6, here 3 2s are 6. And here 2, here 2 nitrogens over. Here we have taken 2 steps, but here we have done in one step. Clear to you? Chalo. Okay. So copy this one. So with this we stop for today. And so practice some other equations already what I gave. Those equations you practice. If you are perfect in this one, tomorrow I am going to take the next topic, that is types of chemical reactions. chemical combination, decomposition, displacement and double displacement reactions I will explain you. Okay? Chalo, right? Did you copy? Take the screenshot then. Okay then. Bye.